Hey guys, this is Kevin from Refixnetwork. Today we're gonna learn how to understand the functional block diagram of a charging IC. Let me start from this one. This is your BQ247880S. Let me go directly to the functional block diagram. Here you go. So there are many people asking me how to understand the functional block diagram. So here is a simple video. You can understand it simply. Before that, you need to understand what is the logic gates. Few of them, not all. So let me open the logic gates. One is your NOT gate. Input is A and output will be the X. And the truth table you can see, if the input is 0, the output will be 1. And if input is 1 and the output will be 0. In logical high, it's 1, that means the pulse will rise high. Logical low, it will be 0 and the pulse will be low, that is 1 and 0. And so if we are giving a high input, it will give just opposite, like it will give you a low output. And if we are giving a low input, it will give you a high logical output. That's your NOT gate. And next one is AND gate. It has two input, AB, and X will be your output. Here you can see when both inputs are high, then only you will get a high output, otherwise it will be low. Next is NAND gate. NAND gate, it's a combination of AND gate and NOT gate. We know the NOT gate will give you just opposite output. Here you can see AND gate, whatever it was like low inputs, just opposite outputs. Here you can see. So these are the basic gates. Actually we need only a few, these only now for the data sheet. Let's come back to the fundamental block diagram. Here you can see the first one is your VCC and there is a Schmitt trigger. Schmitt trigger is just like a comparator. And the first one is your UVLO. And UVLO, the VCC is connected to the lower side and the positive side is your 3.2 volt. That means your VCC must be higher than 3.2 volt. Then the UVLO will be low because the VCC is connected to the lower side. And you know there is a small circle over there. Of course that's your NOT gate. And we know now we are getting a low output for this Schmitt trigger. This is Schmitt trigger. It's just like a comparator. So here you will get 0. But after the NOT gate it will become high. Let me write here, it is 1. Right, and this is an AND gate. For this, it's not an AND gate. Yeah, it's called. We can call it as an AND gate because the NOT is connected before the AND gate. The next one is your AC detect. We know AC detect is connected from the VCC through a voltage divider. All right. So here in the Schmitt trigger, the wake up negative side is connected to 0.6 volt and the positive side is connected to the AC detect. So if the AC detect voltage is higher than 0.6 volt, then your wake up will be high. Now for the AND gate, we got two high inputs, then it will release a high output. Now the output will become high if the VCC is more than 3.2 volt and AC detect is more than 0.6 volt. So the output of AND gate called a EN region, enable region, that's your LDO enable. Here we can see any regulator here. Yes, here is the regulator LDO. For the enabling LDO, it will coming from this point and it will give you a 6 volt LDO output on pin number 24. You will get a 6 volt here. Alright, so let's go back here. Here the next Schmitt trigger is your AC OVP, and its higher side is connected to the VCC, and we know it is 19 or 20 volt, right? And the lower side is connected to 26. So AC OVP, the higher side is 19 or 20, the lower side is 26. Of course, the lower side is higher, then we will get a low output for the Schmitt trigger, and after the NOT gate it will be high, because it's just opposite. It will do the just opposite. Alright, and the next Schmitt trigger is connected to the AC detect, and its high side is connected to AC detect, and the lower is 2.4 volt. So that means the AC detect voltage must be more than 2.4 volt. Then only you will get a high output from the Schmitt trigger. Now we got two high input, then we will get a high output, that will be your AC good. So for the condition AC good, the AC OVP, of course it is adapter current over voltage protection. Okay, it's the input, your VCC over voltage protection. So the input voltage must be lower than 26 volt. If it is higher than 26, it will become high, and your output after the NOT gate, it will be 0. I will tell you what happened if it is the voltage is higher than the 26 and the AC detect voltage is lower than 2.4 volt. So any of these conditions is not matched, then you will get a just opposite output. Like if AC OVP is higher, AC OVP is high, then you will get low input for the AND gate for the first input, and the second is your AC detect. If the voltage is more than 2.4, then only you will get a high output from the Schmitt trigger. If it is lower than 2.4 volt, you will get a low output from the Schmitt trigger. So here the AC good is high now, and the enable region, it's already high here. The third is your VCC SRN. Here we have three inputs for the AND gate. The third one is connected to VCC SRN. Let me check here. There is, yeah, here you go. This is your VCC SRN. Now we know the VCC is 19 or 20 volt, in between the 19-20 volt. Okay, and the lower side is connected to the SRN plus 275 millivolt. SRN, you know where is the SRN, and the higher side, of course, it is higher than the SRN plus 275 volt. Then your output will be high for VCC SRN is high now. The VCC SRN is high. So let's come back to this point. Now we got all high points, high inputs for the AND gate. Of course, we will get a high output here. So now the output will be high. It's coming to the AC OK drive. Alright, here we have a NOT gate. Now AC OK drive is high, but after the NOT gate it is low. It is low. And you can see there is an internal MOSFET connected, and the AC OK is now floating. When any of these conditions like AC good or the LDO or VCC SRN is low, then the output of this AND gate will be low. That means after the AND gate, after the NOT gate, it will be high, and the MOSFET will start like it will get on. Then whatever the voltage is connected, we know it's connected 3.3 pull-up rail through a resistor. It's a 10k resistor or a 100k resistor, right? And a 3.3 volt is connected here. It's from the VPCU. So when the MOSFET is on condition, then whatever the voltage at this point will go to ground. Alright, we will not get AC OK high here, right? So this is how to understand the internal function of this circuit or the block diagrams. Basically, you need logical gates knowledge and a little knowledge. Like I already said, what is the Schmitt trigger? It is just like a comparator. It will compare two inputs and it will give you output according to the input. If the higher side is high, then you will get a high output. If the lower side is high, then you will get a low output. That's a comparator. It's just equal to the comparator Schmitt trigger also. All right. And the gates, I told you whatever the basic gates we need, AND gate, NOT gate, and NAND gate. That's only we used here. I'm taking classes in 4 languages. You can join the classes. Guys, thank you for watching.